And there we go. And good evening to all you YouTube folks out there. Welcome to Blue Marble. And tonight, we've got Judy Bassett here live. We've got Rob Barton live. And I'm sure some others will join as time goes on. So what have you guys been up to?
Well, I've just been beavering away at work. We're still trying to get this new ring laser back in the new laboratory. So it's I'm moving it for the I think the fourth time. So hopefully this is the final one.
Oh, wow.
Yeah, it's growing every time we move it. We're making it bigger, so it's going to be a 17-meter perimeter when it's finally cemented down to the floor of the new regional science building.
That is a pretty good sized laser.
No, it's not the biggest. The biggest
No,
we
no.
had was 120-meter perimeter.
Wow.
That was a challenge. I can assure you, aligning that was no easy meat.
I'm sure. Let's see, we got Charlie Welch in audio on, Sean Hawkins, Repo Sandman out there, WPL. Let's see, Forrest Pfeiffer, it looks like, Citizen 9. Good afternoon to all you guys. Glad you could make it. I'm doing kind of a late stream tonight. I had to, we got a replacement clothes dryer this afternoon, but they couldn't tell me exactly when it was coming. So, I didn't know what to schedule. And I didn't want those guys banging on the door in the middle of the stream. So, anyway, we're all back in business. Any good derp going on that you guys have been hearing?
No, I haven't heard any. I'm not a big listener to the other channels, really. I don't need to lose too many brain cells.
Yeah, I hear that. There's John Rapp and Killer Kev, Don Anders. Howdy, folks. We got some fellow Tennessean in there and a Carolinian, it looks like. Well, it's been relatively warm over here the past week or so, but not really hot. So we've not gotten into the real heat of the summer yet. But that's not surprising. It's only the 9th of June. Our hot months usually July and August. Hey, OALM, how you doing?
Hey, good. I was just listening to Earth is Life over there on the other channel. I said, you're coming out great. At least over here I'm not muted.
Who muted you? Did they mute you?
I've never been unmuted. In
Really?
Earth Awakenings channel, whatever it's called.
Oh, that one. Yeah.
Because of Sean was listening to Whitson's. No, Travis's. I just caught what they're talking about there now. It's a bunch of silliness. And Brian just had a meltdown. Actually, Brian Leakey just calling just a slew of expletives just came out of Brian Leakey's mouth.
Imagine that.
Surprise.
Yep. Well, if he's playing with them over there, maybe he won't be over here tonight. Who knows? Hello, Sean Hawkins.
Hey, what's up? Hey, there's when I was watching it earlier, there was the cavalcade of idiocy. The Witsit was there, and he's not there now, but yeah. There was a bunch of stupid people. Yeah, it was beautiful here too. I went outside, sat in a chair, and fell asleep in the sun.
Wow.
It was great. No jacket, nothing.
Well, you're up on the upper end of California, aren't you, Sean?
Yeah, northern Cal, about midway.
Yeah.
Just we're about halfway between like San Francisco and Eureka, California,
Yeah.
somewhere like that.
Yeah, that's not a
But-
bad part of the country.
We got a lot of clouds and a lot of wind, and so a nice still warm day is kind of rare.
Yeah. I see Eric Hare, Mark 10, Roden no. Let me try that name. Roden, no last name. Mark Verschel. And yeah, got a pretty good crowd already. 35 watching. Thanks, guys. Thanks for showing up. Yeah, I had a bit of a go around with Witsit this morning, I think.
Did you ask him to multiply 5 times 6?
It's 60. Everybody knows it's easy.
Yeah, 5 times 6 is 60, according to Witsit.
Really?
It's
Yeah, I
easy.
I
He
clipped a
said-
video. I clipped him saying that on and posted it to my channel.
Must be that new math.
Too many toes.
It was the funniest 3-second video in a long time.
Oh, you
He
better
got
explain.
it. He got it right the second time. He said 5 times 60 is 300. So he got it right the second time, but he fucked up the first time.
Well, he was trying to make a claim this morning about YouTube censoring him in his channel, and all the Flat Earth channels, and he said you can't Google any of my videos and find them. So I didn't say anything. I just went to YouTube, opened up his channel, picked out the exact titles of 3 of his videos, and Googled them or searched for them on YouTube. But what you got to do is put his actual title and then his name. And when you do that, they pop right up.
Mm-hmm.
So I went back and posted those in the chat and pissed him off. I was trying to ask him how tired he was getting of being wrong perpetually, and they muted me. So yeah.
Oh
There
yeah,
you
I'm
go.
muted over there too. And I'm muted on Earth Awakenings for treating Rakiel Life the exact same way he treated me. He's
Oh,
throwing
yeah.
insults and stuff, and I threw the exact same insults back at him and got muted.
Yep.
So
That will happen over there on that channel. Gigi Little, how you doing?
Doing fine. Just got to get to my push to talk button here. Sorry.
Well, that's okay. That is fine. Well, I thought we might watch a little bit of some of Try Thinking's nonsense from last night. If anybody thinks
Right.
they can stomach it.
before you start, I also wanted to say that I went live and showed Travis Finley on, I think it was Earth Awakenings, and they were talking about the hyperphysics, or somebody referenced the hyperphysics article that Travis plagiarized and changed, right?
Yeah.
And Travis was saying, "Well, I used to have an article up there too, but Sean Hawkins got it taken down." And but he's saying, "Well, that article doesn't mean anything. What some website?" And it's like, dude, that's your website. You what you tried to get published there, so you can't say that that article is fallacious when it's on the same website that you published to. So you just got to see Travis be a little hypocrite. Anyway, go ahead.
Well, that's Travis. I mean, what can you say? Let's see here if I can share my screen with you guys. I think I can.
Yep.
Yeah. That'll show you what I was looking at. Yeah, let's see. I need something else turned on here. Like that. Now we'll show it to YouTube too. How about that? Very cool. Let's listen to this a little bit. Let's see what Bev had to say.
Far as I could get, and so I made a screenshot of that. So here's the side view again, and that's my midpoint, 981. If anybody wants to check this math, that's the chord. It's 28.
Says the elevate.
This is Bev whining about Jesse Kozlowski's GPS measurements at Lake Pontchartrain. For those of you that may not recognize what's going on, that's what it is. So let's listen to this.
5.75 at the
Meters.
midpoint. Yeah, 5.76 here at this side. Meters.
Point, like rounded off to 28.5, let's say, or 28.46 if you want to go to the nearest centimeter. And this is the length from the first level point that I kept in my sample to the last level point.
Right, so that's the first level point to the last level point, and one in the middle that's
So that would be-
5.76 on the level point. He said that.
Yeah.
No, the level point is the line at the bottom, the green one.
What?
From one level point to the other, he was talking
Yeah,
about the line, the green line.
Yeah. And
Not the yellow one.
And the point in the middle is also level, right? Or you think it is? Oh,
Okay, they've already got it screwed up.
Yep.
The line at the bottom that Jesse has drawn in there would be a chord line connecting the starting point, his first point on the bridge, to the last point on the other end of the bridge.
Mm-hmm.
The upper line is actually the GPS measurement of the position of that point, and he just takes 3 points, which is all you need to define an arc. Both ends and any point along it, as long as you know exactly where it is, and you can draw the arc that passes through those 3 points. So they've already got this messed up. Let's see where they go.
well,
Hey,
which point do you think is?
Did you ever see the Simpsons episode where Homer made a website? It's like early in the series, and it's just nothing but dancing hamsters and gifs, and it's just. Well, look at your screen. That's what it looked like.
Oh, okay.
Is
And
the
that's
is
the
the level
distance.
there in that? This
Level
is-
is not a point.
This one is a chord,
It even says
Yes.
chord on.
right?
So
Now,
that's
so,
the line.
So the chord comes from the first level point and the last level point. That's what he said.
Yes.
Yeah? Now, the middle point, which he said was here, the mid point is also on the level, is it not?
Yeah, it
The
is.
midpoint is on the bridge.
Yes, on the level, the same level. Right? It's just that this is a chord. Jesse's drawn
And
a
it's-
chord.
Yeah, and it's 28.457 meters away from the core.
Up.
Yes,
Higher.
exactly. Yeah.
Okay, right. So that's it. This one is higher than the first point and the last point.
Yes.
Yes. Okay. Carry on. There you go.
He does that.
They think
He,
level has a high.
Sorry.
You go.
He does that a lot. You notice he'll say something and he'll repeat the last few words you say, as if like to question your you know to question you. He'll say, all points are level and perpendicular. All points are level and perpendicular. He does that every single time.
Well, he'll replay the same little piece of clip over and over and over again for some reason. I don't know why that's necessary, but certainly turns what would be a 1 hour stream into a 5 hour stream. That's maybe the idea. Let's see what else he's got here.
higher position in relation to the two ends.
Right. Good job, Bev.
But he was confused at first because he said that level one was the blue line, which is the chord. Which I would have to agree with. That is the horizontal distance, the shortest distance from A to B, would be that line. To me, anyway. There's no need for me to develop this 28.5 metre hump in the middle. That obviously isn't there because it's impossible.
So pretty interesting.
But
that,
yet it was measured.
Shape that you just showed us there, Jesse. Would you like to expound on that a little bit?
This shape right here?
Yeah.
What shape would you call that? It's a pretty interesting shape. What would you call it?
I'd call it a curve, Bev.
Vampire teeth?
Like a bow or something?
The guy can't even figure out what an arc is.
Irregular
It's a
curve.
frowny face.
Yeah.
Well, it
You know
looks
what I
curved to
call
me.
it?
Go on.
Ridiculous.
Oh, goody.
It is. It gets worse.
Is that where you're going with this? I mean, it's kind of obvious, right?
Yeah. Looks a little.
He turned it in his computer until its computer broke.
he all he said, "What do you think about that?" And Jesse said, "The shape."
Yeah.
And he said, "Yeah, well, it looks curved to me." They're
Yep.
talking about this right here,
Yep. This
not
this
the bridge.
This
Yep.
shape here looks pretty curved to me. Yep. That's what he's
Well,
talking
similar
about. Have a
to
cup of tea.
Wow.
photography, don't you think?
Yeah. Well, don't let the cat out of the bag yet. Keep in mind, these are level. I mean, if you look at these, except for the humps,
Exactly.
these are all at 5.7, 5.7, 5.7.
Right.
5.7. The thing was built to be level above that water.
Are you okay with that? They're all level. That's what he said. He keeps talking about they're all level above the water. He assumes that that's the shape of the water.
It is.
Just Kozlowski does. That's why the bridge follows it.
That's why it does, because the surface is curved.
Yeah,
Dipshit.
well, he actually measured the
Christ.
curve, so
Yeah.
yeah. This is done with GPS. What he's plotted are the XYZ coordinates. He actually took one about every 30 feet or so as he went across that bridge. But that's the XYZ raw data from GPS. XYZ reference to the ECEF coordinate system that GPS uses. So those coordinates have numbers up in the hundreds of thousands and millions of meters when you actually see the coordinates. But anyway, Bev has no idea what Jesse did. He still doesn't understand it.
Oh. Bad connection. I don't know who that is. It's that bad. I can't hear you.
line looks like what do they call those machines? EKG, the ones that monitor your heart there. Beep, beep. It looks like one of those.
See this? Jesse tries to.
Somebody captured some
convince them.
surveyors out there doing the work. I didn't find any of that, but I did find this article. This is from 2011, and somebody. I haven't read the whole thing yet, but he is talking about computing the radius of the Earth using this bridge. So, so it's interesting. I'm going to take a look at this. I'm just showing you a couple of portions of it, but look what I did.
Listen, famous please. Words. This is brilliant.
I took a sample, just creating that blue circle is the result of doing what's called a three coplanar points in 3D would describe a circle. So I selected one of my beginning points, one in the middle, and one at the end. I'm making sure that I didn't pick one of the humps. I wanted to make sure I was picking, the points here on the level spans.
Right. The lower deck, as I call it.
And bam, there's the radius of the Earth.
Let me pause you here and just
Sure.
and just make sure that everybody in the chat or anybody that's listening right now that may have started reading.
I might bypass that. I don't know whether we get it. Did you hear what he said? Hopefully we'll go back
The
over
chat
it
not
again.
really paying attention. Pay attention here, okay?
This was
Jesse has measured the curvature of the Earth, and he has measured the radius based on that curvature. That's what Jesse did.
I did.
So there is no presupposing R anymore. Okay.
No, we have R.
It has been direct.
And Bev's about to pitch a fit now. He's going to somehow or the other try to claim that measuring those XYZ coordinates isn't really measuring because you now actually have to do some math to go along with it. Amazing. Yeah, you actually do, Bev. The GPS machine doesn't draw the picture for you. It's up to you to do that yourself. Anyway.
The result of doing what's called a three coplanar points.
3 coplanar points.
So this would create flat triangle, so to speak.
Yeah,
So
that's a triangle, right? 3.
No, that's triangle abuse, Bev. It defines an arc, not a triangle. Thank you.
Coplanar points.
So
They're
therefore
coplanar
no
edgewise,
radius.
like as if you're looking at the arc end to end, right? That's the coplanar you're talking about, not looking at it on the side.
Yeah, coplanar in a vertical plane.
Yeah.
Yeah, if you have a vertical plane that passes through those 3 points, that's what he's talking about.
Yeah, it's not coplanar on the horizontal.
No, it's not coplanar in the
Okay,
XY direction.
yeah, right.
What we think of as the XY. It's coplanar vertically, like you took a slice through the center of that bridge, vertically, all the way down to the chord line. That's what Jesse was referencing. But Bev has a real hard time with this.
3 coplanar points. And we
In
go.
3D would describe a circle.
Would describe a circle.
Yeah, Bev.
In 3D,
Coplanar
coplanar strict contradiction.
They could describe many circles, wouldn't they? Because you only need 2 points to describe a circle.
But on that plane.
What did he just say? It would describe many circles. What the hell is he talking about? Anybody? Did that make sense?
He can make a bunch of circles on the same plane. I don't know. Actually, you only need 1 point for a circle.
Well, you
right?
need a center point and some point on the circumference of it.
Well, to mark the circumference. Yeah.
Yeah. That way you could define a circle that way, but With 3 points, we're not talking about the center point. You don't need that. You just need 3 points on the circle.
Yeah, true.
That's true. Any 3 you want. And from that, you can easily figure out the radius of the circle. It's not a big deal. Although Bev's going to try to make it one. Hey, shout out Digital Demonic Davros for $5 Australian. Says, at the age of 12, I was doing quadratic equations and plotting them on XY graphs. Then had to create a YZ graph to plot Z coordinates. Strange that. Yeah, that's about right, Digital. Most youngsters by the age of 12 don't have any problem with this. I don't know what that says about Bev and his crew. Well, yeah, I do, but I'm going to keep my mouth shut.
Plane.
Yeah. 3 points would describe a triangle or the plane.
But this radius should be in the opposite direction on Z coordinate line. So, but if the plane is planar or coplanar, we cannot have a third dimension. Where is the third dimension here?
Right.
Third dimension.
That's part of the trick. So the moment he says 3 coplanar points, you're forced into saying what that plane is. The orientation, right? Now, he didn't say what the orientation was. So what did you imagine? Which orientation of plane did you imagine he's talking about? Because there are 2 very different things here. He's talking about surveying, driving over a bridge, talking about 3 coplanar points, 1 at each end and 1 in the middle.
Oh, so he's creating vertical plane.
Hey, there you go. See, you imagined a horizontal plane, didn't you?
Yes, of course. But
Right.
the first thing you can think that he's talking about horizontal plane.
Yeah, because all of the points are on the same 5.8 meters, right? All the way across. So when he says 3 coplanar points, 1 at each end and 1 in the middle, you would imagine he was talking about a horizontal plane. I did.
Well, not if you saw the picture that he drew, the drawing that he made. I don't know how you could imagine that as horizontal. It has to be vertical. I don't see any way around that. How could you not understand that? It astounds me, the effort these guys put into misunderstanding things.
But that's not what he's talking about. He's doing a little magic trick. He's talking about a vertical plane, but unwittingly, he hasn't realized that there are no geometric vertical planes on his model either, which any self-respecting globe surveyor should know. Never mention horizontal and never mention vertical planes. They can't exist because the geometric perpendicularity would require a horizontal plane, and horizontal planes don't exist either. So fail all the way along. But that's one of his
imaginary.
tricks.
They're imaginary. It's
3
the
coplanar
theoretical thing created with our measurement.
Yeah.
Of course, they don't exist in real life. Jesus.
In no reality that I'm aware of do those planes actually exist physically.
Yeah.
That's idiotic.
Yeah, it's like longitude and latitude. You don't get in a plane to see lines spray painted on the water.
Be kind of handy.
These people are idiots. Yeah, it'd be handy. Well, they actually did put markings, like huge concrete letters and arrows and stuff on the ground before we had GPS and good maps.
Yeah.
So that pilots could, see where they're going from the air. You
Yeah.
can still see them all around the United States.
That's a fact. This is really not this hard to understand, but as I say, these guys, it just always astounds me how hard they're willing to work at misunderstanding things.
Points. Everybody
like a
who's thinking about normal surveying on the elevation, what they're talking about, would imagine they're talking about a horizontal plane, but not Jesse. He's surveying, and when he surveys those points, they're all must be in a direct straight line. 'Cause
Yeah,
that's the only way you could have a vertical plane.
that's right. That's right, Bev. And that bridge is as straight as an arrow. And if Jesse was a little bit off center of that lane he was driving in, it's really not going to matter. You're 6,400 kilometers away from the origin of the ECEF system. You're really not going to see it if it's out of line slightly.
What I was going to say before, it's like they try really hard not to understand something. I had a buddy who he put more effort into not working than he did work. He was so lazy he worked harder not to work than he did to actually do work.
Yeah. Kind of characteristic.
The only way. Hope he didn't swap lanes
Oh, there we go.
when he went over that bridge.
Yeah, that would have
Otherwise,
made
he'd be lying. He wouldn't be able to have a vertical plane.
that would have been a
like
huge
that.
problem, wouldn't it?
But
might have been off
this
that.
is a stolen concept fallacy
What?
that he's about to do. But people aren't seeing it because he's so ambiguous. He's so vague about what he's actually talking about. It doesn't actually make any sense.
Anybody that's ever watched that video that Soundly and Jesse did has no problem understanding it, Bev. Trust me. Just a handful of people like you. You're the only guys that don't understand it. The rest of us get it just fine.
So I selected one of my beginning points, one in the middle, and one at the end. I'm making
One at the beginning, one at the middle, and one at the end. Making sure
that I didn't pick one of the humps. I wanted to make sure I was picking, the points here on the level spans.
Yeah.
So
Point on the level span.
This is one line because this is he's looking from above, I think. So this creates one line and 2 points and one in the middle, but you can see that this is a line because he's looking perspective from above, I think.
Yeah. Yeah, this picture he's got here looks like it's a radius, right? Where's this third point? What exactly is he trying to do with this? This picture bears no relation to what he's talking about.
Best I can tell, that's not Jesse's picture. I don't remember that one. I think this is your picture, is it not? I'm not sure, Bev. I don't remember that. Maybe you ought to just let the thing play.
Wizardry.
Yeah.
Right. The lower deck, as I call it.
And bam, there's the radius of the Earth.
Let me pause.
And he just does say that, and bam. Got 3 points, and bam, radius of the Earth. Magic trick.
No, measurements, Bev. 3 points in space that will not lie in a straight line. That's a curve. Not bam. Wizardry, bam. That's a damn curve. That's what you measured.
Boo, poof. Out of nowhere. 3 coplanar points, a triangle. Boom. There's the radius of the Earth.
There we go, triangle abuse again. You guys need to stop that.
Soundly accepts it. Yeah.
you need to complain about
Apology
that.
here.
Go ahead, Rob.
There must be somebody that looks after those triangles. They're being seriously abused.
Seems to be. It astounds me that someone who claims to have surveying credentials and professes to understand this stuff in intimate detail has that little knowledge of math and geometry that he can't understand.
They can't. They simply can't.
No.
You know, either they're lying through their teeth, or they don't. You know, it's you can't survey without understanding geometry.
That's a fact.
Yeah. Either way, it must be exhausting.
True. I
Has
agree.
to be. Has to be. Yeah, let's see what else he's got.
And just
Sure.
and just make sure that
Their
everybody
arms must
in
be
the
like
chat,
massive
everybody's-
from like all the hand waving, all that exercise you get from hand waving all the evidence away.
Yeah, I'm surprised they don't go airborne at times.
listening right
Listen
now
to
that may
this.
have started reading the chat and not really paying
No, it's
attention.
the
Pay
weight of the
attention.
BS that
Okay.
keeps them on the ground.
This was
Jesse has measured the curvature of the Earth.
No, he
And
hasn't.
he has
Damn it, Bev! Eat. Mute your mic and eat, or stop eating. That's irritating and rude, buddy.
measured the radius
No, he
based
hasn't.
on that curvature. That's what
Yes.
Jesse did.
I did.
So there is no presupposing R anymore. Okay.
No, we have R.
It has been directly measured by.
Right? He's soundly telling everybody that what Jesse just did there was directly measured the radius of the Earth.
I got some bad news for you, Bev. Here's Blue telling you the same thing. And Sean and Rob and OALM and Judy and Gigi and Carl K. Everybody with half a brain is going to tell you the same thing. The radius was measured this way. Jesse can get fairly close to it. Even though it's a short segment, you can get really pretty damn close to the accepted radius of the Earth.
Ridiculous.
Of course not.
Yeah, I know, but look how easily he's
For
fooled
the Earth to be
soundly.
flat, that number has to be absolutely huge. You know, it has to get to infinity or close to it.
Yeah.
And they don't understand that any value that's a small number, and what I mean by a small number, you know, anything in the thousands is a small number compared to infinity, and they just don't get that.
No. They don't have any understanding of that. I agree.
That little bit of wizardry that Jesse Kozlowski just did, Soundly's
whether
fallen
R is
for it.
6,000, 10,000, you know, you compare that to something by 10 to the whatever figure that you've got for infinity, it's massive, and so it's not flat.
Yeah. No, it's
You're
not.
just arguing about what R actually is.
Yeah. Yeah, the only question is how accurate is your measurement.
Yeah.
It's not that it's might be flat, straight, or whatever you want to call it. No, it's not that at all. It can't be. It cannot possibly be. And this is not hard to do. My God. They give you, I mean, the GPS system gives you XYZ coordinates for each point. You can get that vector, as any grade school kid probably knows, simply by the square root of x squared plus y squared plus z squared. That's the length of it. That's how far it is from the center. And it's only after you apply, actually subtract the height of the ellipsoid at that point, and then apply the geoid to it, that you get the elevation that we're accustomed to seeing on our handheld GPS devices. That by itself tells you the Earth had to be an ellipsoid, or something awfully damned close to one, or it would never have worked in the first place. You wouldn't get those bridge elevations that are very accurate any other way. But these guys don't seem to understand that.
But Jesse, this is the bit that surprised me. Jesse agreed with him. He went, "Yes, I did."
So even if you repeated
Unless
that
that's his
experiment with a consumer grade GPS, you would still get a value of R. It might not be as accurate, but it wouldn't be anywhere near flat.
No, it won't be. That is absolute fact. Most consumer grade type GPS equipment won't really very handily or easily give you the XYZ coordinates. It goes ahead and massages all that stuff. Adds in the or at least applies the geoid to it, even if it doesn't apply applies the ellipsoid, even if it doesn't apply the geoid to it.
Check coming from that.
Not really paying attention. Pay attention here, okay? Jesse has measured the curvature of the Earth, and he has measured the radius based on
You got to make a short clip of this.
Jesse has measured the radius.
I see what you mean about.
Reckon.
I see what you mean about repeating things.
Yeah.
20 times.
Yeah, you guys talk for a second. I got to step away for just a minute.
Yeah, they really are something. I mean, they might as well argue that the houses are flat. You know, we've measured those too. It's just remarkable.
Okay, I'm back. Let's go a little more.
He did.
I did.
So there is no presupposing R anymore. Okay.
No, we have R.
It has been directly measured by Jesse.
Big claim there, right?
Wow.
Yeah. Did you see how he did it, or did you miss it? Magic trick. Jesse, he did this. Everybody, take note here. Did you see what he did? Do you want to hear it again, just in case you missed it? This is quite impressive.
Computing the radius of the Earth using this bridge. So it's interesting. I'm going to take a look at this. I'm just showing you a couple portions of it, but look what I did. I took a sample, just creating that blue circle is the result of doing what's called a three coplanar points in 3D would describe a circle. So I selected one of my beginning points, one in the middle, and one at the end. I'm making sure that I didn't pick one of the humps. I wanted to make sure I was picking, the points here on the level spans.
Right. The lower deck, as I call it.
And bam, there's the radius of the Earth.
Let me
see that.
Oh yeah.
I know you did. We'll leave everybody else guessing for a bit. We'll come back to it at some other point. But
I mean, does he think that someone showing the measurements, explaining the measurements, explaining how it shows curvature, showing it in the calculator, he thinks that's magic?
That's what he keeps saying.
Okay. All right.
He's trying to convince himself, I guess, and the rest of his listeners that that's actually some kind of trick.
Yeah. That's called gaslighting.
Yeah, gaslighting. Just lying is what I call it, but whatever. Far be it from me to call Bev a liar.
Oh, I'll do that for you.
Spell casting.
Pause you here and just make sure that everybody in the chat or anybody that's listening right now that may have started reading the chat and not really.
Soundly's about to distract you.
This was
Jesse has measured the curvature of the Earth, and he has measured the radius based on that curvature. That's what Jesse did.
I did.
So there is
He
no
didn't.
presupposing R.
Oh yeah, he did.
Okay.
No, we have R.
It has been directly measured.
It hasn't.
By Jesse Kozlowski.
No, it hasn't.
During Globe Earth Tourism 2019.
Yeah.
So
Roger that.
Globe Earth Tourism 2019. What a good year.
But
Did it age well?
I noticed that Kozlowski, he said that he computed.
Yeah.
But this guy said that he measured. So if someone would accuse Kozlowski that he is lying or double speaking, he would say, no, I said I computed. This guy said I measured.
Yeah, but he did agree with him. Yeah. He agreed wholeheartedly. But I mean, who wouldn't?
Right, and you measure the slope of a roof by computing the rise over the run. It's the same thing.
Yeah, it is very much the same thing. These guys love to try to tangle themselves up in that sort of pedantic bullshit argument, but that's all it is.
Yeah,
just a ridiculous, pointless argument.
Love that, right? Oh yes, I did. Oh yes, I did.
Oh yes, he did.
He didn't, but I mean, he's got Soundly to believe him that he did, and now Soundly's telling everybody. And now, did everybody hear how Jesse did it, or did everybody hear Soundly saying that Jesse had done it? Because I say that's a shadow giant.
Say that.
A shadow giant. That's another odd term that they like using. Will someone please explain to me what a shadow giant is?
Not a clue, dude.
Anybody? I have no idea. Bev says that all the time. These shadow giants hide under beds and, swing down out of trees, I suppose. I don't know. Makes absolutely no damn sense to me. But that's just part of his babble.
Because he's about to,
No sense
he's
to
about
me
to do
either.
something here at the end. If you pay attention, he's going to turn to Jesse and beg the question. Because he adds on that, right?
Yeah.
Play it, listen.
R is no longer presupposed.
No, it's actually
was.
It's monumented.
In the monument to the curvature of the Earth.
20 some miles long.
This idiot doesn't even know what monumented means. Has no idea what that meant. But he's a surveyor. He has surveying credentials and doesn't know what a surveying monument is.
Yeah, I want to say something about that. He claims to have gotten a certificate. He calls it a license, I guess, a certificate in surveying, where he had to take a test.
Yeah.
In order to take a test, you need to read books. He said he's never read a book. So I doubt that he even has that certificate. Has he even shown it?
Yeah, he's shown.
I think.
Oh, has he?
I think he just has something from like a trade school or like one semester in continuing education or something, so he could lay out a foundation or be a carpenter. I don't know.
Yeah. I mean, even if he went to a trade school, they'd require him to buy a book, course book. So, I mean, is he trying to seem smarter than he is? Oh, I never even had to study for that test. I didn't have to read any kind of book. Is that what he's pulling?
Who knows?
Well, it's all right line. It's all right line geometry. It's all right there. It's all right line.
And welcome to Larry GPS. How
Yeah,
you
did I
doing?
miss anything?
Not a lot. No. It was just Bev went back over this Pontchartrain thing and screwed it all up again last night. So I thought I might just have a little fun.
You only missed one thing 20 times.
Well, yeah, it's a typical Bev stream where he has to, his memory is so short, I suppose, or his listening abilities are so poor, he has to constantly back up 3 or 4 or 5 times and listen to the same little piece of tape. It's amazing.
Well, he probably thinks of more snarky things to say about it as time progresses, so he has to keep going back. And
Larry? Did you get the point he just made that where he obviously doesn't understand what monument means? Did you catch on to that?
No, but I know Ordnance Survey has those observation pillars like all over the place that he makes reference to. Look, they've got all these concrete pylons, and they're all triangulated with horizontal distances. So those are the monuments. So he's talking about them. I guess he doesn't realize that a concrete pillar that's trapezoidal in shape is a monument.
Yeah.
Well, English is not his first language.
Yeah, let's see what else he's got.
So, so here's what happened.
I thought Leakey was going to be here with his flat Earth proofs.
Oh, I haven't seen him. He was on Jose's show for a while.
Yeah, but he's talked out.
Yeah, either that or he's over there at Geo's place, something like that. But anyway, we'll let Bev mess this up some more.
I did a comparison of what.
Well, that's why I
had
to write down some facts about what he said about Maine Surveyor and his Alberuni being all over the place.
Yeah, I think he might have been wrong about that.
Yeah, he's over on Earth Awakenings.
Yeah, that's what I would figure. Anyway.
This myself,
That's right. You did not
these 3
sit there and calculate.
I did not sit there and calculate it myself. No, listen to the words he uses.
But he said before that he
measured it. He measured it. Now he's saying he didn't even calculate it himself. Somebody handed it to him. The calculations.
I'm not at all sure that's what he said.
He said it was just all over the place. It was just all crazy. And I said, well, what's crazy about a perfectly good-looking, respectable, tight angle that returns 7/6R?
Yeah. That's not all over the place.
7.08. Yeah, 7.08. And my refracted radius from a plethora of observations, not to an ocean horizon, also got 7.11. So we're almost identical.
Yeah.
He's doing a dip angle, and I'm doing elevation angles. He's using ocean horizon. I'm using a fixed target at different distances.
Yeah.
Repeatable science, different methods, different maps, different. And I didn't use, so anybody knows, I had made a whole bunch of vertical angle measurements to a radio tower at various distances, and not using curvature or refraction, just figure in the right line geometry, should get the elevation just like, flagpole in the parking lot like you did in high school, right?
Yeah.
Well, you look at all the elevations, they decline purely by distance. Now, I didn't use geodetic software. I used least square best curve fit, and it came up with the same radius refracted, 7/6, as Maine Surveyor.
Yeah.
Oh. Who did?
They have a funny definition for words
The
because
7.6,
directly
the
measured.
7/6R. That's not fictitious, and I always hate the way it sounds, but that's just an easy way to remember.
Larry, are you watching my live stream in Discord?
Tuning in now.
Yeah, because I'm playing this Bev thing, and you're not hearing it. So if you're not watching it, you can't hear it.
Oh, so I got to do it on YouTube, huh?
No, not YouTube. All you got to do is go up there and click on my name.
Yeah, well, I got.
Or-
Yeah, I have a static screen now, but
Yeah, it's not running at the moment.
got the peach,
I've got it.
peach with its head sticking out.
Yeah, I've got. You should be able to hear it right now.
To me, is different than using this online curvature calculator and measuring a little bridge and saying you directly measured the radius of the Earth.
From what? Can you remember? Or did the wizard trick work on you? Hopefully the songs haven't gone past you by that we've been putting out.
The three
coplanar points.
Coplanar points.
Yeah.
I caught that too. Jesse would use the term, he would say he calculated, and then Soundly would say he measured, which are two totally different things.
Yeah, you're right, Brandon. Calculating and measuring are complete opposites.
Exactly. So
And then
first
just
Wrong.
didn't do it.
he took this data
That
with
sounded
the
like
GPS. It gave him elevation.
Right. Yeah.
So he's got these elevation points, and then using his WGS 84.
Nope, that is not what he did, Brandon. Or that sounded like Brandon. He did not take the GPS elevation data. He took the raw XYZ coordinate data, and from there, that's where he talks about calculating. Now you've got to get the distance from each of those XYZ points back to the origin. That's what Jesse did. The points were measured, but there is a calculation involved. It's still a measurement. Damn, how do these guys get this so screwed up?
Our model, right?
No. He took the points, right? Yeah, we took the points. The ones that we had for the chord, they were the first point and the last point. So he showed us the chord, and then 1 point from the middle that's on the level, right?
Which was 28 meters.
Which was
up.
28 meters higher. So, if they're three coplanar points,
But it wasn't 28 meters higher. It was at the same damned elevation.
Bev knows. Oh, sorry.
However, when you plot those points, they do not form a straight line. They form an arc.
Yeah. I mean, Bev knows this. Bev absolutely knows this. And the way we know he knows this is he was going to do this with those levels. He was going to show that all three, the center with and the end, they're all going to be in a straight line. He said, well, you need to measure between the endpoints, and then he completely dropped it. He didn't want to do it then because we caught on. We caught on to the game he was playing. And he knew that doing it the correct way would show curvature.
Oh yeah, it took about a split second to find the flaw in what he's doing.
Yeah. He's not dumb, he's just dishonest. And a little dumb.
Yeah, there might be a combination of things going on here.
It's just low budget trickery, though. It's just sleight of hand.
Yeah. Are you hearing it okay now, Larry?
Wizardry.
Oh.
Oh yeah.
Yeah, okay, good. Make sure everybody's on board here. Let's listen to some more silliness.
what plane would they be in?
Cross section of the Earth.
Exactly. It makes no sense. That's
So
the
would
only...
would those 3 points describe a circle?
Yes.
Yeah.
No, they would describe a triangle. That's what 3 points do. Surely.
they could describe a triangle, but in his case, what he's using it for is to work out the dimensions of the circle.
Yeah. So that you've got a higher point in the center with a different elevation.
No,
I mean, I can open up. I
you
can
don't.
open my. Oh, sorry.
No, I'm just going to say, no, you don't have a higher point in the center, Bev. They're all at the same elevation above mean sea level. The problem is mean sea level is not a straight line. Mean sea level is a nice curve.
If you open a AutoCAD, if you open any AutoCAD program and go to draw a circle, it gives you a choice: center point, circle on 2 points, circle on 3 points. I mean, what does not? What, Jesus.
Yeah, well, no, you leave CAD behind. Let's just go to any old geometry book, and 3 points can describe an arc, okay? And an arc has a center. So CAD software, being software junkies is where we've all fallen down, right? Let's go back. My favorite textbook's 100 years old because there's nothing different today except 100 years ago, it was all verbose because it was all pencil and paper and log tables.
Right.
Yeah.
You learn a lot more when you do it the hard way, like how to write software.
It's a lot more work. That's for sure. It's super easy on AutoCAD, yeah. You pick a point, a midpoint, and an end point.
Yeah, but that's where a lot of quote surveyors that say they curvature refraction, we don't do that. Well, their instruments do it for them. So yeah, we're software junkies.
Oh yeah.
Yep.
So,
I'm guilty.
Yeah.
Although I did learn drafting by hand first.
Yeah.
So
if you take the 3 points on the bridge in the ECEF coordinate, it don't take software to do the x squared, b squared, c squared to get a uniform distance from the center of the Earth.
No.
Right.
No.
Yeah, but the really cool thing about it, and this fascinated me when I sat down with that data because Jesse didn't analyze it this way. But I looked at that after I did calculated the distances from the center to each of those points. And I said, no, wait a minute. The southern point is further away from the center than the northern end of the bridge is. I wonder why that is. Oh, wait a second. The Earth is an ellipsoid. What do you know? That's exactly what it should be. It should do exactly that, and it does. So you can get all kinds of good information out of that GPS data that Jesse measured. Lots of good stuff, not just the radius.
And that's why satellite geodesy is in ECEF.
Yeah.
Because of the simplified math that goes into positions and different distances. You want to take it to ellipsoid? Pick whichever one you want.
Yep. Yeah, you can apply whatever you want to it. It clearly works because in the post-processing, where Jesse goes ahead and says, here's what the GPS would return as an elevation, not just a point in space. All those elevations match the distance above mean sea level of the surface of that damn bridge. But it only got there by applying an ellipsoid and WGS 84 to it. It's the only way it could get those numbers.
Which is ad option.
Yeah.
Yeah, it's a completely ad option.
Yeah. Exactly.
Why would you make
take
a
those same
circle out of
ECEF
that?
and You could take those same ECEF and put them in UTM or state plane or or latitude longitudes. Ad option.
Yeah, whatever you want to use. It's up to you.
The 3 points. You're developing a fourth point. Obviously.
What?
It's called the a circumcenter of a triangle. It's the point in which you can develop a circle around the triangle that cuts every point on the triangle is encompassed on the circumference of the circle.
What was that word?
Circumcenter.
Yeah.
Okay.
It's known in the trade as BS, probably.
About when he used to throw around the word perpendicular.
Perpendicle, yeah.
I like that.
Is that anything like antarcing?
Similar.
No, antarcing is actually made up. I think there is such a thing as you can call it circumcenter, as I recall. It's rarely used.
I've heard circumscribed.
Well, yeah.
You sure he wasn't thinking of circumcision?
Yeah. Thanks. Maybe he needs to be a little more circumspect.
Okie dokie.
That's what Jesse's doing. It's a very strange way to be able to develop a circle from a triangle, specifically the triangle that what he's done there. Very strange.
Yeah, now we're into high school geometry. Any 3 points make a triangle, and any 3 points can define a circle. Absolutely, they're not mutually exclusive. When he said, "Oh, that's a strange way to develop a circle," you go, "What do you mean strange? It's right there in your fucking freshman high school fucking textbook."
Yeah. Yeah, to Justin Franks out, is it Justin? Yeah. He is pointing out that it's a circle that passes through all 3 vertices of a triangle. Yeah, right. That's exactly what it is. And that's basically what you're doing when you define an arc with 3 points. That's what you've done. It's essentially exactly what you've done.
Yeah, 3 points, draw a triangle and a circle at the same time.
Yeah. Yep, absolutely.
It's quite opposite because you are drawing circle and then you can inscribe triangle into diameter. For example, how to create or prove that there is a right angle triangle if you have diameter and the angle on the circle will be always straight right angle. So you can move this angle across the circle and it will remain the same all the time. Will never change. It will be always. But this is Pythagorean theorem. I saw this on some page. There are animations for that.
Yeah. It's all based upon Pythagorean. It's all triangles. All you're doing, or what Jesse's trying to do, playing a magic trick, he's just assuming that the base of the triangle that he's developed with an imaginary spot that's higher in the middle is a chord. Now, chords, geometrically, are perpendicular to the tangent that passes through the center of the chord. It's a fact.
What? What did he just say? Chords are perpendicular to the tangent?
That passes through the chord.
Does that make sense?
No, not at all. unless the chord is a hemisphere, is is equally bisecting the circle. That's the only way that could be true.
I'm gonna do a Bev and play that part again. I want to hear it again.
The only way a tangent could be perpendicular to a chord is if the chord was 90 degrees to the tangent running down the center of the circle.
Let's just listen to him.
Always, but this is Pythagorean theorem. I saw this on some page. There are animations for that.
Yeah. It's all based upon Pythagorean. It's all triangles. All you're doing, or what Jesse's trying to do, playing a magic trick, he's just assuming that the base of the triangle that he's developed with an imaginary spot that's higher in the middle is a chord.
Well, that's not a magic trick. And the two ends of the bridge are at the same elevation. And a line between those 2 points would be a chord, assuming the Earth is a spheroid of some sort. Would it not? No magic involved in it, Bev. Jesus.
Now, chords, geometrically, are perpendicular to the tangent that passes through the center of the chord.
That's what I thought he said. Chords are perpendicular to the tangent that passes through the center of the chord. We're going to clip.
That's the only way that could happen is if the chord ran through, if it divided it sideways, not, horizontally, but vertically.
I realize he probably just misspoke, but I'm going to make a note of the time, and we'll cut that little part out. That's 3:08:04 thereabouts. Good, because I think I need to play that about 15,000 times, like he does any time I misspeak.
It's a fact. Parallel. Because they're both at right angles to each other. It's how you find the center of a circle. I mean, it's a geometric fact.
And he just said it's parallel. It's a fact. If you parallel, because it's perpendicular.
Yeah.
Good God, man.
He's just stitching words together
Yeah.
in some random order, hoping
is,
that they make sense.
This is worse than triangle abuse. This is geometry abuse here.
You're not
it's like
seeing
he took
the
a
magic.
box of those, like he took a handful of those magnetic words you get from like Spencer's or the novelty store, and threw them up against the refrigerator and didn't reorganize them. Just left them there, and that's his brain.
Yeah. two left thumbs. It says it right. He says he's conflating chords and normals. Yeah. Absolutely, he is.
Trick. Then, any 3 points can develop a circle from them, because that's one of the geometric facts of triangles. They're very closely related to the circle, because the circle
He's
is just
admitting
an
that
accumulation of points.
triangles make circles. He's confusing himself.
Yeah, he's pretty good at that.
Every triangle will fit into that method. Interesting how Jesse thinks he's going to do it. 28 meters is an actual rise in the center of that bridge. 28 meters higher than both of the end points. Shout out, Blue.
Oh, well, thank you, Bev. Thanks for shouting me out. And no, it's not 28 meters higher. The elevations are the same. We'll just keep telling you that until maybe one of these days it sinks in.
You know what he did? He measured the elevation across the bridge.
Yeah. Yeah, he absolutely did measure the elevation all the way across it. And it's all the same elevation. About 5.7 meters above mean sea level. And the distance from the center of the Earth is, well, for all intent, the same at each point. Problem is, that's from a center point. So those 3 points on that bridge cannot lie in a straight line with each other. It's not possible. And that's what's so beautiful about that work that Jesse did. That set of GPS measurements is very definitive. It's exactly the way it should be.
Bridge, and that's all the same horizontal. But
all
he presupposed
5 point
Earth
something.
curvature, and he added 28 meters to the center. Then he took that presupposed curve, and then he created a sphere from the sphere that he used to create the bending horizontal.
That is a crock of shit. That is not what Jesse did. Not at all. Those are actual measured GPS points. Those are actual points in space. That's the data he measured and collected. And that's the data that he used and I've used, Larry's used, everybody's used to analyze the shape of that thing. Walter Bislin. We all come up with the same answer. We probably all do it slightly differently from one another, and we still get the same answer. The damn thing follows the curvature of the Earth.
Exactly. That's what I was getting at. Exactly, Clary. Well said.
Mm-hmm.
I don't know if it was well said, but yeah.
Well, I understood it.
Yeah, he described the process earlier when he said
No, it was clear. I guarantee you it wasn't well said.
they start with the state plane and they convert to a globe and then they go back to the state plane. He's just showing us the middle part.
Yeah.
How they do it.
Yeah, that's all like not. Like they were all coplanar. But I mean, for them to be coplanar, I think you're assuming that they must have been driving in a dead straight line. Because I mean, when I think coplanar, especially since he said that he'd made a plane across the bridge at the beginning on the water level, he makes a triangle of 3 points to establish his plane. And then obviously the only thing he can do is measure an elevation rise of 28 meters in the middle of that bridge.
Is this Bev show recent?
Yeah, it was last night.
And he's still confusing curvature and elevation. Still.
Yep. Cannot get that through his head.
He doesn't want to.
I'll say it again. The elevation is above mean sea level across the level parts of that bridge, ignoring the little humps that are there for marine passage. And the level parts of the bridge, every point measures somewhere right around 5.7 meters above mean sea level. Every one of them. But then when you compute the distance each point is from the origin of the ECEF system, they're all about 6,400 kilometers. And if he moved his vehicle over 3 meters one way or the other, it is really not going to change the number enough that you could ever even find it. It would be a tiny, tiny difference in the magnitude, the distance from the center. Very, very small difference.
Which is impossible. Because water can't put itself into a negative pressure state. I don't think the water's even that deep.
Water can't help itself out.
Yeah, it can't conform to what the surface underneath it either, can it? Right, so yeah, the water levels, I mean... Okay, so there's a contradiction. Because Jesse Kozlowski is the man that said the water level drops away from the horizontal, but that seems to rise whenever he shows a hump. Because the horizontal would be the chord, and there's a rise, not a drop.
Wrong again, Bev.
Oh.
Wrong again. Take that cord, draw a line parallel to that cord, and park it up on top of that center point. And you know what you'll find? Then you'll find the water is dropping away from that horizontal, just like we've always told you. Hey, shout out to Wallace Bow for $20. Thank you so much, Wallace. Hey, Blue, I believe his rambling geometric statement is about the perpendicular bisector of a chord. Yeah, I think that's what he was trying to say, but he just didn't get around to saying it.
.28.5 meter rise from that. Because that one, the line that at least that Blue imagines to be a chord, is horizontal. However many points you want to imagine it's horizontal at.
1 point, Bev. 1.
But it is.
90-foot hump. Yeah.
Shut up, Meg.
I've got some other windows here now.
So I don't know what he's about to get off into at this point. But I thought it would be fun to go through that and just listen to the idiocy coming out of those guys.
I mean, they say the same thing, but it's never surprising.
Yeah.
I mean, it's always surprising. It's just surprising how ignorant they can be, how bad and wrong they can get it.
Hey, Jeff, I got Jesse on message. How do I make an invite? Or can I?
You can, yeah.
Go up to the top and click on the where it says BMS server and it says invite people. Or the drop down, I mean.
Yeah, when you click on that bar up there that says BMS.
Yep.
It ought to give you the option to send an invite. Be great to have Jesse drop in.
Yeah, it would.
Well, I think he will. Because he said, give me a link.
Be interesting to get Bev in here, too.
No, Bev's not coming in here.
Oh, no.
Well, he's not coming in here because he's banned.
Oh. Okay.
There's only a couple of people that I won't forgive and go ahead and unban them. Bev's one of them. Rocky is another one.
Yeah. Someone made a comment that Rocky's a bully. I said, no, Rocky is not. He's not. He's a bully's friend. Rocky doesn't have the pull to be a bully.
Rocky is just a garden variety narcissist, that's all.
Yeah.
There was some more stuff in this video.
He says he's a Cajun, but he just sounds like a ignorant South Florida, Florida Southie. That's what he sounds like.
No, he sounds Cajun to me.
Does he? I don't hear any Cajun. Don't hear a bit of it.
Yeah, let's see. We'll see what. Oh, Bev goes on his whiteboard. Let's see. That's got to be entertaining. Let's see what happens over there.
Okay. With respect to the water level, the observer height of the theodolite is 124 3/4 inches. So that is 10 feet, 0.4 feet, 10.4 feet, okay, above the surface of the water when I set it up. And the target is at, let's see here.
Yeah, he's talking about something that came from George Natchik, obviously.
Yeah.
I didn't listen to this whole thing. Hell, it goes for 5 hours.
Holy.
That's crazy.
How can they talk for so long about so much that's wrong?
I don't know. They make a habit out of it.
I think one of the reasons why a lot of flat Earth videos are so long is because they know that people want to debug them.
Yeah.
They know that most of us won't sit through 5 hours of video. I think that's one of the
Yeah.
reasons why they're so long.
I agree. They bury the dirt. You know, they
Yeah.
just go on like platitudes and diatribes, and that is over a flat and stationary plane, and you know you have to sift through 4 hours.
Yeah.
To get
To
to
get
that.
to the few sound bites that might be useful.
Yeah, I noticed that Phuket Word used to do that. He was the first person I noticed doing it. He just for 3 hours, and like the climax is the dirt. But
Yeah.
you have to sift through it.
Yeah.
Yeah, it's either that approach or they do something like Lindsay Harris does, where the whole thing is such incredible derp. It's just a random mishmash of words that don't connect with each other. So at the end of the day, you sit and think, well, I probably should debunk this, but I don't even know what the hell I'm debunking.
Yeah. It's like trying to debunk something in Martian. First, you got to learn Martian.
Yeah.
Debunking a non sequitur. Yeah, that's like trying to teach a fish to ride a bike. I mean, it doesn't. It's a non sequitur. So what do you do with it?
I have to do this a lot in my job. I have to translate something into English that hasn't been thought out correctly in their own language yet.
Right.
So I have to take schizophasia and translate it into a complete thought. It's often impossible.
Yeah, when you have to learn a second language and then a third language, which is really the syntax of the second language, it didn't quite work out.
It's like trying to build a house that someone dreamed up in their sleep.
Yeah, and it looks like an MC Escher.
Yeah, exactly.
Wait a minute. Frank Lloyd Wright was good at that.
Yeah, he was good.
And all his houses leaked. Some of them fell down.
There was a family in my neighborhood that had built their deck around a tree. They had a big tree in their yard. They didn't want to cut it down, so they basically built the deck, or like the porch. It wasn't a deck; it was a porch with a hole in the roof around the tree. Pretty interesting. Sitting on your porch with a tree in the middle of it.
Oh, dear.
Trees get old, and then you got a problem.
Yeah.
Or they get bigger.
Well, it was made so it would accommodate the size of the tree. I think you put like a rubber skirt up there.
Yeah,
there's a lot of trick shit you can do. incorporating trees, without having to take them down. There's a lot of nice things. And a deck, even if the deck gets destroyed, it's not like you're out, big money.
Yeah.
Seems like most decks have about a 15-year lifespan.
Yeah, about that. Depends
Well, it's
on
hard to say because every 5 years you're repairing part of it. So at the end of 15 years, it's the most of it is only 10 years old.
Everything around here is on the West Coast is built with either redwood or Douglas fir, so it lasts a long, long time.
Well, everything around here is built with Home Depot wood.
Yeah.
That's a special tree type.
Yeah, plywood from the
One of the
great
guys was
mighty
crying.
ply.
One of the guys was trying. He got a load of 2x4s, and he said the ring spacing was over a 1/4 inch. I mean, this shit is balsa.
Holy crap! We have we're also a logging town. They used to have a sawmill here that basically built the town, and right by the city hall, they've got a section cut out of a log.
Well, the
that's
actual
like 50
value should
feet
be
in diameter,
372,000,
and it was a seed before Christ. It's over 2,000 years old. Pretty amazing.
And then there's the Methuselah tree. They cut it down and realized, oops, it was 5,000 years old and still alive.
Damn.
That's a famous one. Some naturalist went in there taking a core sample for his dendrochronology, and he broke the core. So the park ranger said, well, we'll just cut it, take a slab out of it. And they realized, oh my God, this thing was alive?
Uh-oh.
It took them months to count the rings.
Jesus. Yeah, they've got like nails stuck in it and little placards pointing to the nails, and each on like significant rings of what happened in history in that year of its life. It's a neat little display.
Yeah, like the Byzantine fourth century ecumenical.
Yeah. And the birth of Christ isn't even in the center. It's like about 3 or 4 inches from the center.
It's Old Testament.
Yeah.
Yeah.
I hate those Liberty Mutual Cup commercials, except for the one with the kids like Liberty Bibbity. He's the actor that keeps getting the finger on it. It cracks me up every time.
Yeah, exactly.
Liberty Bibbity.
Yeah, I was just going to put the Pontchartrain Bridge picture up. This is one of Soundly's pictures, I think. So that's really that's what Bev's been yammering about.
That's not curved at all.
This thing really pisses them off. The curvature is so obvious when you see it from the right perspective.
Yeah.
It's not hard to make yourself realize that, yes, there is a 90-foot sagittal in the center of that damn thing.
And there's no miraging, no mirroring.
No. So you do that, and then you simply do this. Maybe my cursor's showing. It looks like it is. Where those two red arrows are pointing at the starting and ending point of the bridge. And if the Earth were flat, because this is all coming from all this information comes from an origin, then that line, that vector from the origin to the center of that chord line, that bisector, would have to be shorter than the outside vectors would be, right? Have to be. Problem is, it's not.
Did you take Jesse's coordinates and rotate them to get this drawing?
No.
Or this is a sketch?
This is just a sketch. Just to demonstrate the principle involved here.
I didn't know if you had rotated and translated his coordinates.
No.
That's why in all the textbooks everything's always super exaggerated. All technical drawings are super exaggerated because what do you do with a 5,000-foot radius or a 4,000 mile radius when you're only dealing with 30 miles?
Right. Exactly.
Mm-hmm.
Well, I think somewhere in here I show what the problem really is when you plot it. That's what we really measured right there. That sagitta up there. And you find out that, there's the XYZ data, typical for one of the points. And this is, that's X.
What's the 1183? The first column, the
11,833.
That's X. That's the X coordinate, 5,570,000.
Oh, okay. So the 63, the last column is the distance to origin.
Right.
Okay. Yeah, I didn't know which column was X and which column was the last column. I wasn't sure. Yeah.
Yeah, I pulled them out down here in this lower panel and showed X, Y, Z. I just pulled the data for the 6 points that I selected. And let's see. We skip forward a little bit in the let's see, I was showing actual positions. This is a video on my channel. But there you go. So I took that same, this front part, first part, is that same little panel that we were just looking at a minute ago. And there's the XYZ data, and the vector length then is the square root of x squared plus y squared plus z squared, right? So those are those vector lengths. But this is where
you could have taken that vector length and put it in miles just to see the 3960.
Yeah, I could have, should have, probably didn't. But V1 is up here at the top, V3 is in the middle, V2 is at the bottom. Okay. V1, V2, V3 you see on the sketch over there. And you notice there's 108 meters difference on that northbound lane from the, I guess that's the north end of the bridge and that's the south end of it. Yeah, which one's bigger?
And for those of you playing at home, that's 3,959.8 miles.
Imagine that. No, actually, it looks like the north.
Which may be accurate for that latitude.
Yeah, it is accurate for that latitude. So, John Rapp out in the chat says, "What's the length of the bridge?" It's about almost 24 miles. I used a little shorter distance than that. I wanted to be sure I was, nice and solid at the ends before it started transitioning to, some elevation of the ground. Yeah, I wanted to be sure I was on the deck. So I think I've got a little less than 23 miles total But you notice in both cases, both the north and southbound lanes show right around 109, 108 to 109 meter difference from the upper end of the bridge to the lower end of the bridge. And that's the elliptical shape of the earth that you're seeing. And someplace, let's see, maybe it's a little later. But here's a panel. This is AutoCAD. This is the reason why we don't draw these things to full scale. This thing over here on the left, that is one of those vectors drawn to scale. And the little part of the bridge we're looking at is up here in this red circle, and you can't even see it. It's too tiny to even see.
Yeah, well, 23 miles. Yeah, that's like 1/3 of 1 degree, you know.
Yeah. But when you plot it, and these are distances in, what are these in
Meters.
feet? In meters? Yeah, they're in meters, right?
18,609.
Yeah, 18,609 back to that end of the bridge, and 19,166 to the other end. So I wasn't quite in the middle. Yeah, sort
You know,
of.
if you take that block right there and turn it into a block and then reinsert it in your drawing, you can change the Y scale.
Yeah. Yeah. That can be done. But when you plot the damn thing, then you get 28 meter at that point. That's not quite in the middle yet either, keep in mind. But at that particular point, it's 28 meters from the chord line up to the actual curve defined by those 3 points. And this is not me doing anything. This is AutoCAD. All I did was point at that and ask it what the radius was. That's the number, 6,342,337 meters. That's the curve that fit. So, and I think that's the other lane. And I think that's what Jesse came up with. So he picked different points than I did, so you get slightly different sagittas, quite obviously. But I found it interesting and pretty much irrefutable as far as I'm concerned. I don't know how you look at this and say the earth is flat. Can't be. Not possible. Say hello to Joe Whip. I see he's joined in. How you doing, Joe? And Shaky.
Hi.
This listening to the
How you cut out, Joe?
I'm doing well. I'm just sitting here listening to all the derp.
Yeah, there's
No
always
derp here.
There's plenty to go around.
Shortage of derp on Discord, is there?
No shortage at all, no.
Oh boy. It just gets better and better. Yeah, I was hoping Jesse would join
Is
in.
it possible these flat earthers get dumber and dumber? Is that even possible?
Nah, I think they bottomed out a long time ago. They're just bouncing along the bottom at the moment.
I think they fell through the bottom of the barrel.
Yeah.
The center of the earth.
No, I think the barrel has no bottom. It's like a singularity. So you can also fall deeper.
There's Bunny Killer and the long hair, and John Rapp. Hey, John Rapp. 9 o'clock hero. Real Cygnus. Let's see, we got Lefty and Mark and all kinds of people. Hey, thanks for showing up, guys. Yeah, this was just sort of impromptu. Like I said earlier in the stream, we purchased a new clothes dryer, and they couldn't tell me when it was going to be delivered. It was just sometime between 1:30 and 5:30, so I decided best not to schedule anything until that was over with. Hate to have the dryer delivery guys beating on the door in the middle of the stream here. So. Yeah, we'll probably make this a short one tonight.
Everett blew.
Mm-hmm.
Everett, was it within the window?
Yeah, they made it. They made it about 4 o'clock, I think. Well, a little later than that, probably 4:30.
Time. Between 12 and 5 and 6 o'clock, they're still not there.
That's usually what happens.
It kind of ruins your day.
Yeah. Well, these
Show up at
guys.
all and you get a call saying, "Oh, we're rescheduled for next week."
Yeah.
Because they've gotten so bad.
There used to be a lot of. Oh, sorry.
I don't want to call anyone out particular, but FedEx Ground during COVID has been hiring independent contractors, and our driveway is fairly steep. And the package is down. The FedEx Ground driver puts them to the top of the driveway, and then kicks them down the driveway. We actually had video of the one guy doing it.
Oh, wow.
That's not the way FedEx deliver your package.
Mm-mm.
It's been a common complaint. The neighborhood patch and all that crap.
Yep. John Rapp says radius 3959, length of arc 25 miles, Sagitta 104.19 feet. Yep. Sounds about right, John. That's about what we would expect. That's
yeah,
beautiful.
Well, the day before yesterday, when I mentioned with Leaky Online, I said, well, I did a 3-point Eratosthenes and got the radius, 3960. He goes, you mean 3959? Oh, no, actually, for my latitude and my azimuth, it was 3963, which was 25 parts per million off a priori.
I think that's pretty acceptable.
Yeah, and I threw that at somebody else. They go, parts per million. That's always used for like liquid concentrations. Why would you use that? Actual quote, and then a bunch of people jumped on that. No, that's just the statistics of when 0.1% just doesn't do it. 0.00001%. Oh yeah, now we're in parts per million.
Yeah, that's.
And I had and I had Jesse and the guy in Maine and myself all working simultaneous, and everything had to come together because that radius is a maximum. Any mistakes would have made that radius shorter. So it all had to work. So there's a lot of moving parts because we're shooting the sun and we're not on a meridian and we're 520 miles apart and we got within about 1 arc second of expected with theodolites and stopwatches.
Yep.
Do that math.
Yep.
And it took us 2 tries to do it. So the first try, we only had Jesse and I, which was 260 miles. And then because the third guy had a scrub, and then we did it again, all 3 of us. So for the one segment of 260 miles, I have 2 measurements, and they're like within like 1,000th of a mile of radius. So when I said 3963, it's 3963 point, like, 62.98 or something. It's ridiculous.
Yeah, done properly, you always get the right number. We get exactly what we expect, time and time again.
Devil's in the details. Devil's in the details. And the guy in Maine and Jesse and I, we had done others with the sun much lower in the sky, so we had a couple of dress rehearsal. We call them training runs, and it's okay. We're going for the big 520-mile arc, and so we were on our game with having drilled a couple of times prior on different shorter segments, always returning 3960 something.
Well, these are not trivial measurements to be making, and as you say, the devil is in the details. And for some reason,
And I did not use the ephemeris elevation of the sun. All 3 of us shot the sun was setting, so all 3 of us shot the upper edge of the sun, and all I used was that edge, just as being a simultaneous point. So it's just a point in the sky at that point. I'm not using any ephemeris data for what the elevation of the sun was. We just measured to the upper edge. It could have been the moon, could have been a star. In this case, it was the upper edge of the sun. And then I figured what that would be to center, and that was within 1.5 arc seconds.
Yeah.
And refraction only made about a 9 arc second difference. So considering that's been studied for 500 years, I figure I get to use that. Okay. If I didn't, it would have made that radius a little bit shorter. So the 3963 is actually a maximum. I had stretched it out as far, every kind of mistake or inaccuracy would have shortened that radius. Now, there's 2 segments, 260 miles and another 260 miles, and Jesse was in the center for like less than a quarter meter. I mean, he was exactly centered. And now I have a southern segment radius and a northern segment radius, and they're different, but also matching the ellipsoid. So there's 3 radii. There's the 520-mile segment, or the individual 260 miles. All 3 of them are a little bit different, which is because of the geodesic. The Earth has no radius.
Yeah, funny that.
It has domature.
How much?
Well, the different radii they're quoted are, one is a perfect sphere that's of the same volume, and one is an overall average. So that's why you get the 3959, 3960, 3961, depending on what your criteria is to make that average. So the one that's most commonly used is a perfect sphere of the same volume of Earth.
Humpature. That's the word. Humpature.
Yeah, see, George was Con and George have joined us. How you doing, George?
Hey, George.
Oh,
Hi, George.
had a had a busy day working in rototilling the garden.
That sounds like hard work.
Yeah, it was. It pretty warm out, and then finally waiting for things to dry out a bit. Lake has reached a new historic high for the area. A lot of people flooded out, but from all the rains and stuff, my garden was pretty mucky. So took this opportunity this afternoon. It was dried out enough where I could get prepared to plant.
What are you going to be planting, George?
Oh, corn, peas, beets, cucumber. I like using fresh beets for making borscht. You know.
Yeah.
Ukrainian borscht beet soup.
Never had borscht.
Comes out blood red.
That's nice.
I've had it.
I'm not a big beet fan. I do like them pickled, but I just can't handle the flavor of like boiled or. Yeah, not a fan.
Well, what you do is you make a beef stock and then add sliced beets to it. But the trick is not to boil it. If you boil it, the beets will turn white. So you got to heat it up just to the point of boiling, and then the soup will remain a nice, brilliant blood red. And then, as Ukrainians will add sour cream to give it additional flavor.
Yeah, I knew the sour cream is mandatory.
But that's my favorite soup.
I like a good potato soup. Or New England clam chowder.
Yeah, clam chowder and wild rice soup is my next favorite.
Yeah, I do like a good potato soup too. Got a recipe somewhere or the other. You know it's going to be good when it starts out with 2 pounds of butter.
Yeah.
Got to be good, right?
Yeah. Had a Norwegian woman always say, everything tastes good with butter in it.
I used to make an ice cream that had 2 sticks of butter per pint.
Oh my.
Yeah. It's good.
Excuse me. I love this thing you posted there, Sean, with why was Bev in Shameless?
Yeah.
That looks good. Oh, so what's the current nonsense that Bev is?
Oh, it's the same thing. He's a one-trick pony. He doesn't have any other argument than this.
Yeah, it's amazing how these guys year after year can just be discussing a handful of Euclid's postulates, and verticals are parallel in that, and they don't get any further.
Mm-mm. Well, I've got something I got to get to, so I'll say goodbye to you guys.
Yeah. Take
All
care,
right.
Sean.
Good stream, Blue.
Yeah, thanks for dropping in, Sean.
All right, later,
Love
fellas.
some of your videos that you post on about Bev.
Oh,
I
right
get
on.
real got it.
Later.
See you, man. Yeah, we've been going for 2 hours, and I thought we'd hang around a little while and see if Jesse Kozlowski was going to join us, but he's probably tied up.
Oh.
Be good to talk to him, but anyway.
Was Jesse going to show?
Wasn't sure. He asked Larry for a link or an invite to the channel,
Okay.
but that was half hour ago or so, I think.
Yeah, it ain't happening, I guess.
Yeah, I think not.
Well, Jesse, I know, has been pretty busy with his new job and new responsibilities.
Yeah, and he's
Yeah,
pretty.
his new job. He's been there for like a year, so I think we can drop new.
Okay.
I think he's pretty fed up though with flat Earth altogether.
Yeah, they pretty much burned him out.
Yeah.
Well, it gets
Yeah.
kind of time consuming if you're going to edit videos, right?
Yeah, it
Yeah.
gets very time consuming. That is a fact. Well, I think I'm going to say good night to the YouTube crowd if you guys don't have any objections. And
Well, especially gets tiring just regurgitating the same stuff over and over.
yeah,
I mean, like Sean said, he's Bev and his crew are pretty much a one-trick pony, and they just beat the same subjects to death over and over.
When's the
It
next-
gets tiring.
When's the next live?
I'll probably do one tomorrow night. If you want to let him know.
Yeah.
Yeah, Larry, that's a nice graphic, that last one you posted with the zenith and the angle with latitude to the sun. I like that.
Yeah, like I said, the Earth has no radius.
Yeah.
Well, the best part is that's 520 miles. That's almost the same distance from Alexandria to the well that Eratosthenes did.
Yeah, Cyrene. Yeah.
That's a full 2% of the circumference of Earth.
Yeah.
There was something posted earlier today that I really liked. Let's see if I can find that graphic someone posted. I think it might have been Truth Nerds or Genesis, and can't remember. Trying to find it. Yeah, here it is. Oh, WS posted it. Here, I'll copy it. Image. Yes. That one there. I love that.
how does that work?
Yeah.
Seems like we have a problem here.
Perspective.
Yeah. Big time. Well, all right, YouTube crowd. Thanks for showing up tonight. I'm going to say good night, and we'll probably do, I think I'll probably set the stream up tomorrow afternoon around 3 o'clock, something like that. Maybe 4. And we'll do it again. So, say bye-bye to YouTube, everybody.
All right. Good deal, Blue. Thanks. Somebody take, or where's Wally? I think, or Woo. Bev likes Wally. So why don't you take that image from WS that I just posted there, Wally, and take it to Bev and have him explain it.
Yeah, I'll give it to Wally.
And
all right. Hey, there's Wally.
I'm out as well.
Okay, Larry, you'd be good, buddy. Good night, YouTube. I'm ending the stream at this point, so we'll see you later.